ওকে, ওয়েলকাম ব্যাক। আচ্ছা, আজকে আমরা প্রথমে আগের দিন আমরা সরলরেখা সমীকরণ পর্যন্ত আলোচনা করেছিলাম। ইন দ্য লাস্ট ডে I stopped my discussion ending with the discussion with the straight line. Okay, now today let us consider an elementary equation about the circle. আচ্ছা, আজকে আমরা একটু বৃত্তের সমীকরণ নিয়ে আলোচনা করি। ধরা যাক একটা বৃত্তের সমীকরণ x² + y² = a², সিম্পলি x² + y² = a²। ওকে, x² + y² = a²। এই বৃত্তের ক্ষেত্রে এর কেন্দ্র মূল বিন্দুতে বা 0,0 বিন্দুতে আছে এবং এর ব্যাসার্ধ হচ্ছে a। The center of the circle remains at the origin, that is 0,0, and its radius equals to a. So, if we draw the circle, it will be just like that. So, it is our x-axis and it is our positive y-axis. It is the center of the circle. Let it be taken as the origin, that is 0,0, and the radius of the circle, it is a. Radius of the circle is a. So there are 2 points of intersection of the circle with the positive x and positive y axis. Also there will so the coordinate of this point, it will be a, 0. Coordinate of that point, it will be 0, a. 0, a. There may be other such similar type of points with the negative x axis, negative y axis, the points of intersections may be found. Okay. Now so this is the equation of the circle with the radius a and the origin is at the center, or its center is at the origin, that is 0,0. Now let us consider a general equation in 2 degree in x and y. Let it's x² + y² plus 2gx plus 2fy plus c equal to 0. Now I shall explain that this also represents a circle with its center at the point -g, -f, and the radius equal to square root under g² plus f² minus c. Now, a general equation, let x minus alpha whole square plus y minus beta whole square equal to a square. It represents a circle. It represents a circle with the center is shifted to the point alpha comma beta and radius equal to a. So, it represents a circle with center alpha comma beta and radius equal to a. Okay, now with the help of this equation I shall find out the radius of that circle represented by the equation in second degree in x and y, and with the corresponding location of its center. Okay, therefore x² plus 2gx, the above equation can be written as x² plus 2gx plus g² minus g² plus y² plus 2fy plus plus f² minus f² plus c equal to 0. So rearranging the terms, we can get x plus g whole square plus y plus f whole square equals to g² plus f² minus c. Okay, so this equation may be written as, I am going to the top of the board. So this equation may be written as x plus g whole square plus y plus f whole square equal to root under g² plus f² minus c whole square. So comparing these two equations, this and these equations, we get alpha equal to minus g. Similarly, beta equals to minus f, and a equals to root over g² plus f² minus c. So the center of this circle lies at the point. So the center of the circle lies at the point minus g comma minus f, center alpha comma beta, that is minus g comma minus f, and the corresponding radius a equal to root g² plus f² minus c. Okay, now there is a simple conclusion from the above discussion, that say this circle may be drawn like that. So it is that circle with the center is at the point alpha comma beta, and I have simply taken alpha and beta to be positive, so it is situated in the first quadrant. It is an arbitrary, and the radius of the circle equals to a. So it is our x-axis, it is our y-axis. Okay. Now, if the center of the circle is situated at the origin, that is, we have x square plus y square equals to a square. Now let a point x1 comma y1. I have to find out whether this point is situated inside the circle or outside the circle. So if the distance of this point from the center, of the circle is less than that its radius, then definitely this point will be inside the circle. And similarly, if the distance of this point measured from the center of the circle is greater than the radius of the circle, then it will be outside the circle. So distance of that point from the center, it is simply x1 square plus y1 square. If it is less than the radius, then the point lies inside the circle. That is, if x1 square plus y1 square minus a square is less than 0, then the point remains inside the circle. Similarly, if x1 square plus y1 square minus a square is greater than 0, then definitely the point will remain outside the circle. Okay. Now, another important conic section equation, which is most important in physics, like when we shall deal with the projectile motion equations, we shall find that the path traced by the particle projected in the two-dimensional plane, that is preferably taken as the xy plane, the trajectory of the projectile will be a parabola. So let us draw our attention to the simple discussion about a basic elementary discussion about parabola. Okay. Now you all know the familiar form of a parabola may be of several types. Let we write its y square equal to 4ax. Y square equal to 4ax. Okay. Now what is the definition of parabola? Parabola is the locus of sets of points, on a plane such that the distance of a particular point on that locus is equidistant from this focus and also from another straight line known as the directrix. Okay, I am again repeating, parabola is a locus of sets of points taken in a plane such that all the points, so a particular point is equidistant from a particular point of the parabola which is taken as the focus, and it is equal to the distance of the particular point from another straight line known as the directrix of the parabola. Okay, now the focus of the parabola remains over the straight line known as the symmetry axis of the parabola. It may be y-axis, and in some cases it may be x-axis, or in some cases it may be parallel to x and y-axis. Okay, so y square equal to 4x. How to draw? You all see that if y is plus or minus, x is always positive. So, and it always passes through the origin, that is 0, 0. This equation is satisfied by the point 0, 0. So I can write, it is y, it is our x-axis. So it is the corresponding equation of the parabola. Look, its vertex is at the 0, 0, and its axes are x and y axis respectively. So its focus will be at the point a, 0. Its symmetry axis is the x-axis, and focus, as per our definition, focus is a point placed on the symmetry axis of the parabola, as the symmetry axis is the x-axis. So focus is situated at the point a, 0 of the parabola. Okay. Now, similarly, if we write y square equal to minus 4x, then for all positive values of y or negative values of y, x is always negative. Okay, so that type of equation will be like that. Okay. And obviously its focus will its axis is symmetry axis is the x-axis, preferably here it is the negative x-axis, and its vertex is at the origin, that is 0, 0, and with its focus is minus a, 0. So it is y square equal to minus 4ax. Similarly, if I write say x square equal to 4ay, x square equals to 4ay, it is another equation of parabola. You see that if x is positive or negative, then y is always positive. And also, like the previous example, this parabola also passes through the origin, that is the point 0, 0. So, and what will be its symmetry axis? Its symmetry axis will be y axis. Its symmetry axis will be y axis. So focus will be situated what the y axis. So it is that type. So it is our x and it is our y. It is the vertex of the parabola, that is 0, 0. Okay. Now the focus is a point which is placed on the symmetry axis, that is the y axis. Focus will be 0, a here. It is the location of the focus. Now I am again repeating, any point situated on the parabola is equidistant. It will be equidistant from the focus and also from the directrix, which is a preferably straight line. Which is a straight line. Any point on the parabola will be equidistant from the focus and also from the directrix. Similarly, if we just write x square equal to minus 4ay, if we just write x square equal to minus 4ay, then for all positive values of x and y, y is found to be negative. That is, it will be like that. So its vertex is also situated at 0, 0, and its focus will be at 0, minus a. Okay. Now let us get another type of equations in a slight complicated way. Okay, these are the basic forms of parabola. Okay, now I am returning back. Sorry for the late. Okay, let the equation of a parabola. Let the equation of a parabola is simply represented as y equals to a into x minus h whole square plus k. Let it is a general equation of a parabola. Y equal to something a into x minus h whole square plus k. So if I write this form in the like that, then its focus will be at the point. Its focus will be at the point h, a k plus 1 by 4a. Its focus will be at the location h, k plus 1 by 4a. K plus 1 by 4a. Now obviously, what is the axis of that parabola? Now you can write this equation in the form that y minus k equals to a into x minus hs square. So the vertex of the parabola is situated at the point h, k. Vertex of the parabola is situated at the point h, k. Vertex h, k. Okay, vertex of the parabola is situated at the h, k. And how to draw this type of parabola? Say h and k are positive. It is our x, it is y axis. Okay. Now vertex is at h, k. h comma k, I am assuming that h and k both are positive. So that, and when you draw this type of graph, you will preferably find that the point of intersection of this parabola with the x and y axis. Okay, to find out the point of intersection with the y axis, you can put on the y axis x equal to 0, and for the x axis you can put y equal to 0. Okay, so let this type of parabola, and obviously another important thing, that it does not passes through the origin. Let this type of parabola, I have written like that. Let it is this type of parabola. Let, for simplicity, and its symmetry axis is parallel to the y axis. Okay, let us redraw. The vertex should be at h comma k. So I am redrawing the graph, and again it is x, it is our y. Then it is this type. This type of parabola is this. Okay, let it is this type of parabola. So it is h comma k. This is our h comma k, and the focus is at h comma k plus 1 by 4a. Okay. So I don't know the value of a, so it is difficult to put the focus here. Focus will be situated over this line. It is parallel to the y axis. It is our symmetry axis. Okay. This is the vertex. So it may be a figure like that. Now let us give you a simple example. That I am drawing a simple example. Let the equation of a parabola is given by y equals to minus x minus 3 whole square minus 2. I have to trace the graph. Y equal to x minus 3 whole square minus 2. I have been asked to trace this graph. Okay. Now you find that it is of the form y equals to a into x minus h whole square plus k. It is of the same form. So I can, and just comparing these two forms, I can say that it is the equation of a parabola. In physics, it is sufficient. Okay, and in your mathematics class, you will deal with this problem in a vast way, in a great deeper way, in a most deeper way. But in physics, for the tracing of the graphs, I am discussing the preliminary ideas just. So comparing these two equations, it is a parabola. I first conclude. Now, what is the vertex? Now you can write the equation y plus 2 equals to something x minus 3 whole square. So its vertex will be, at 3 comma minus 2. Its vertex will be at 3 comma minus 2. Okay. Now how to find out its focus, location of its focus? Now comparing these two equations, you find that a equals to minus 1, h equals to 3, k equals to minus 2. A equal to minus 1, h equals to 3, k equal to minus 2. So the coordinate of its focus is given by f h comma k plus 1 by 4a, that is 3 comma k is minus 2 by minus 1 minus 4, that is 3 comma minus, that is 9 by 2. 3 comma minus 9 by 2. One by 4. Okay, sorry, it will be 9 by 4. 3 comma minus 9 by 4. Now let us draw this type of parabola. So obviously, and what is its axis? Its axis is, what is its axis? Its axis is parallel to y axis, or the axis is vertical. So I have calculated the coordinate of the focus as 3 comma minus 9 by 4 and vertex at 3 comma minus 2. So let us draw. Now you all see that if y equal to 0, then x minus 3 whole square equal to minus 2. Okay. So vertex is at 3 comma minus 2. In this way, it will be vertex 3 comma minus 2. Okay. And what is its focus? 3 comma minus 9 by 4. minus 9 by 4. Now to check whether the parabola intersects the positive y-axis. If you see that if x equal to 0, I am just checking, if x equal to 0, then y equals to minus 3 whole square minus 2, that is minus 9 minus 2, that is minus 11. So the parabola intersects the y-axis at minus 11, and similarly for the x-axis, if I put y equal to 0, so it may be like that, not passing through the origin. Obviously you remember that it does not pass through the origin, okay? It is not the origin. Now focus is situated at 3, minus 9 by 4. 3, minus 9 by 4. Okay, so it may be the corresponding parabola. It may be the corresponding form of the parabola. Sorry, I've done a little mistake here. Let us draw again. It is x, it is y. Vertex is at 3, minus 2. So it will be like that. It is our 3, vertex 3, minus 2. And the focus is like that. Focus is here. It is 3, minus 9 by 4. Sorry, this will be the corresponding parabola. And its directrix, where will be its directrix? The directrix is a straight line which is equidistant from the equidistant from any point taken over the parabola and from the focus. Okay. So if you want to draw the directrix here, say this is the equation. This is the straight line, which is the directrix. So any point, say I am considering only the vertex of the parabola. Vertex will be equidistant from the directrix and also from the focus. Okay, equidistant from the directrix, also from the focus. I am again assuring you that the drawing is not as per scale. Okay, I have just drawn the corresponding shape. Okay. Similarly, let us draw another type of parabola equation. Say I have been asked to plot this type of graph. Say y equals to x square plus 2x minus 3. Y equal to x square minus 2x plus 3. That is, we can write it in the form y equal to x square plus 2x plus 1 minus 3. That is x plus 1 whole square minus 4. Or y plus 4 equal to x plus 1 whole square. So comparing this equation with the standard form of a parabola, we see that it also represents a parabola. Okay. Now the center of there is a vertex of the parabola, vertex. It will be minus 1, minus 4. Vertex of the parabola will be at minus 1, minus 4. Now let us check the coordinate of its focus. So I am comparing this equation with y equals to a into standard form x minus h whole square plus k to x minus h whole square plus k. That is, comparing these two equations, I have a equals to 1. You check this equation with that. A equals to 1. 8 equals to minus 1. k equals to minus 4. So coordinate of the focus, it will be h comma k plus 1 by 4a, that is minus 1 comma minus 4 plus 1 by 4, that is minus 1 comma minus 15 by 4. Minus 15 by 4. Okay. Now let us try to sketch the parabola. Okay. And you all see that when x equal to 0, y equal to minus 3. X equal to 0, y equal to minus 3. That is the parabola intersects the y axis, y equal to minus 3. So 0 comma minus 3. When x equal to 0, I am again repeating you, x equal to 0, y equal to minus 3. That is, if 0 comma minus 3 will be a point on the parabola. And similarly, if y equal to 0, then what is the value of x? That can be solved from this equation. Okay, now, what will be its axis? Its axis will be vertical, or symmetry axis will be vertical. So, vertex is at minus 1 comma minus 4. This is the vertex, minus 4. Okay, now it intersects the y axis at the point 0 comma minus 3. So it may be like the graph like that. It may be the graph like that. Okay. Now, what is the coordinate of these 2 points? Say here y equal to 0. Y equal to 0 means here y equal to 0. If y equal to 0, then you see from this equation, if y equals to 0, that means x plus 1 whole square equals to 4, or x plus 1 equal to plus minus 2, or x equals to plus minus 2 minus 1, that is x will give you the result 1 comma minus 3. 1 comma minus 3. So coordinate of these 2 points, it is here y equal to 0 and x equal to plus 1. So it is 0 comma 1, and another point it will be 0 comma minus 3. I have already said that the graph is not as per scale. So these points should have been shifted like this, and it will be its symmetry axis. And what will be its focus? Its focus is minus 1 comma minus 15 by 4. So this type of points will be focus, because minus 15 by 4 is less than minus 4. Negatively less. Okay, so this type of form it will be of that parabola. Let us now consider the basic equation about ellipse. Okay. Now you all know the familiar form of the equation of an ellipse is that x square by a square plus y square by b square equals to 1. You will have a greater importance of this type of elliptical curves when you will deal with the trajectory of the different type of planetary bodies, or different types of objects under gravity, or different types of planets and their satellites. Okay, there are different elliptical paths concerned with the discussion in Kepler's laws for planetary motion. Here we shall consider you have to draw the detailed type of elliptical paths. It may be sometimes it may be parabolic, maybe sometimes it may be elliptical, sometimes it may be circular, etc. But in those cases, in dealing with the trajectory of the planetary objects or different type of planetary motions, elliptical paths have greater importance. Okay. Now x square by a square plus y square by b square equal to 1, it represents an ellipse. Its semi-major axis is A. A equal to length of semi-major axis. And B, it is the length of semi-minor axis. B is the length of semi-minor axis. That is, and the center of the ellipse is at 0, 0. Center of the ellipse is at 0, 0. And with its axis is x-axis and y-axis. Axis of the ellipse is x and y-axis respectively. Axis of the ellipse. Okay. Now let us draw. This type of ellipse will be like that. So it is our x, it is our y. Okay. Now the eccentricity of this ellipse is given by E equals to root under 1 minus b square by a square. So this point will be 0 comma b, that point will be 0 comma minus b, that point will be 0 comma a comma 0, and that point will be minus a comma 0. So this is our major axis, this is our minor axis. Okay, just wait, I am coming after a few minutes back.